How do you define innovation? What does the word mean to you?
Well, I think to me, innovation really is about change, like directed change to achieve a benefit. So innovation in the context of an industry is about doing something differently to achieve a certain objective, whether that means making more money or reducing the impact or, somehow providing benefit to others by doing things differently. So to me, the fundamental thing about innovation is not doing the same thing all the time. You're doing something new.
Maybe on a basic level, we could divide the mining industry into two types of people. You're either the sort of person that builds a bridge, or you find the river in the first place. As the connectivity of our world matures, finding the river is becoming different. The process is changing. But once we reconstruct the narrative in hindsight, this change is obvious. Last week, we talked to Dave Kingston. If you haven't listened to that episode on the Rover Boys, I suggest you do so now. It's a great story, a galloping story, that like any good tale, takes a rather unexpected twist at the end. Dave was a geologist experienced in surface mapping. But what his work led to was a multi-trillion-dollar transition of the oil industry to more offshore environments, and ultimately it brought about his own career demise. A petroleum geoscientist today looks nothing like Dave Kingston. They look very different, they quack very different. So the question is, what does this transition feel like, if not this? What kind of evidence, facts do we need to put in front of you to convince you? In a world where one can validate any opposing hypothesis, find any dissenting view, I question what is required to convince you, to get you to openly, intellectually, and honestly question where we are. Do we need to change? To be honest, I haven't asked myself that question. I consider myself to be a field geologist, and I think I'm quite good at it. But the question I have to ask myself, am I going to be required in the future? Both Steve and I, we're really fond of the Kodak story. There's no finger pointing or angst here, but more just the question, what does it feel like in the middle of a transition? Does change actually feel like change when you're in it? For those of you that question the need for change, are you still waiting for your photos to be developed? In today's episode, we talk to Andrew Shook about the future of innovation in our industry. This is really the future of change. So come join us and let's explore.
Hi, my name's Andrew Shook. I did a degree in chemical engineering in the University of Saskatchewan, and then I did a master's and a PhD in a much warmer part of Canada in Vancouver in metallurgical engineering. So after I completed my PhD, I married an Australian girl, and even though she was quite happy staying in Canada, I dragged her back to Australia. So we moved to Australia. I got a job in Newcastle working for BHP.
After joining BHP, Andrew spent nearly 20 years in the company working in a variety of different roles. This experience included working in their steel business, in copper smelting, briefly in titanium, uranium, and in their research and technology division. After leaving BHP, Andrew spent 4 years with Rio Tinto, where he held general manager positions in innovation, surface mining and automation, technology platform, and future business technologies. These roles involved the development and implementation of new mining technology within the company.
So where did the interest in research or the technology side come from? Was that something that you got during your postgraduate research?
At that time, there was a very famous guy running the metallurgical department, leading metallurgical engineering research at UBC. His name was Keith Brimacombe, and he was very much focused on innovation in metallurgical processes. So things like new pyro processes or hydro processes, steel casting, steel making, all kinds of aspects of metallurgical processes. Keith Brimacombe was really a world leader. And so one of the reasons why I went to UBC, apart from the weather, was an opportunity to work for that guy. And so when I did my PhD, it was very applied. I mean, I was working directly with a large Canadian mining company. So it was very applied, very direct, and really kind of the sort of thing I ended up doing, ever since.
Earlier, you gave kind of a definition of what you think innovation is. How much of a commercial aspect to innovation do you think exists? Should that be part of the definition of innovation?
Well, I can only view innovation from the context of having, worked in a company. So I think of innovation as serving the needs of a company. And, the purpose of the companies I've worked for are, to make money and not to hurt anyone and to minimize the impact on the environment. So the purpose of innovation within a company is, does it do one of those things? Does it help you make more money, return better value to your shareholders, your stakeholders? Does it stop people getting hurt, do things safer, or does it minimize the impact of the environment? If it doesn't do one of those things, it doesn't really belong, in that company. So I guess that's the way I think of innovation. I mean, innovation for the sake of innovation, I think first off, it's actually really hard to do because you really need direction. And there's that, that well-worn phrase about necessity being the mother of invention. I actually think it's true. Without having an objective, I think it's very hard to invent something. From my point of view, directing innovation for a benefit is extremely important. And I can't think of it otherwise. I'm sure there are people who just innovate and think of things, but that's not been the way that I've worked.
We're going to talk a fair bit about the AusIMM Bulletin that you contributed to. You mentioned that innovation in mining is different to other industries. Do you want to elaborate why you think that?
Yeah, I think there's sort of a number of reasons, but innovation itself can obviously confer great benefits, but it often comes at high risk. And one of the attributes of the mining industry that's critical in order to understand it well is that it is a risky business. As you guys well know, exploration geologists well know, figuring out what's in the ground is incredibly hard. And so there's an enormous amount of risk that comes with being a mining company just from the ore body itself. The ore body risk is massive. So even with well-defined ore bodies, knowing exactly what you're going to get is actually not possible. And so there's a huge amount of risk in the ore body. And there's also, multiplying that, is the commodity price risk. Mining companies are price takers. We don't set the price. So if you multiply that ore body risk times commodity risk, you have at the very beginning an enormous amount of inherent risk. And everybody knows lots of mining companies go out of business. It is a difficult way to make money. All companies face risk, but mining companies face two risks that they can't control and they multiply together. And so if you've got that inherent risk, once you're actually successful, once you're actually thinking that you're going to make some money, there's a very real reluctance to multiply that risk by another factor. So by that I mean, say you've got your ore body risk and your commodity risk, and somebody comes up to you and says, you know what, I think you can make 10% more money off this mine before you open it. Now there's going to be maybe a 2% chance that it'll completely fail and you'll go bankrupt. But you'll make 10% more money. And that is not attractive to most investors, and rightly so. Coming with untrue, untested technology in an area is a very, very hard sell. And so mining companies naturally are reluctant to deploy new technologies that are not really well tested. And finally, once you have a mine up and running with sort of the tried and true technology, generally, if you're successful, you're making money and you're paying off your debts. And remember, I said innovation's about change. Well, that can be very disruptive when you've got a process that's actually working properly. So again, imagine you've got a mine, it's working, it's returning value, and it's not impacting the environment adversely, and laws are being followed, and somebody comes up to you and said, you can make 1% more money, but there's a chance, you're going to have to shut down for 6 months, and there's a chance that, it'll be longer than that. And again, that can be not a very attractive thing. So again, the risk and disruption associated with change and innovation are difficult things for mining companies to absorb, despite the fact that there are likely to be very real benefits. So you put all that together, and innovating in mining, it can be extremely challenging, and especially if you're an external service provider or technology provider trying to convince people in mining companies should embrace a new technology, that can be a very tough ask, and there are good reasons for that.
Yeah, you've covered the 2 points where I think mining is different, is A, the scale of it and the investment required. Yeah, the point you made is absolutely right, that the amount of money involved, you don't want to take on any more risk because you're already taking on a substantial amount of financial risk to go through that venture as it is.
Yeah, it's like the incremental benefit versus the risk. So if you've done your analysis, you've gone and asked for your money from the banks on the basis of tried and true technology, you know that if the ore body turns out the way that you hope and the prices are the way that you hope, that you're going to get a good return. And you borrowed the money probably based on conventional technology. To do that and then change to, unproven technology is hard. Or to get the money when you're saying, well, you're staking everything on unproven technology, that's hard too.
So one of the perspectives that always interests me for innovation is as we come further and further down the grade curve, which is an inevitable consequence of surface-based ore bodies, the uncertainty associated with, or the heterogeneity associated with these ore bodies is going to increase. What concerns me is there must be a time where that leads to a behaviour of taking on new risk, which is essentially sovereign risk, over trying to tackle the technology risk or the exploitation risk of mining lower grade ore bodies. There has to be a trade-off where we have to get better at mining and extraction versus doing what we already know but going somewhere else to do it.
No, it's an extremely good point, and I couldn't agree more. Taking on sovereign risk to go to some other place that has got a higher grade that allow you to make money with conventional technologies versus technological development to secure a good return on your now somewhat depleted ore body. That balancing of the risk and the technology is, I think, absolutely an important question. Yeah, I mean, all I can do is agree with you, but say that the pace and development of metallurgical extractive processes often isn't there. The rate of development often isn't there. So unfortunately, those mines will tend to close, and people go and hunt for the better stuff in other not so nice places. But yeah, I totally agree with the point.
So we face this in exploration all the time, where the bird in the hand, the classical intertemporal choice. You take something that you've got right now that might be marginal versus the option of something better, but you stack another risk on top of it. And essentially we learn by failure, it seems, rather than with any foresight. We'll need failure to drive innovation rather than foresight.
Yeah, that's quite right. And I actually think people tend to view, the country risk as something that is either can be quantified or understood or managed, whereas technical risk is again, is something we really don't have a good handle on. So I think in terms of scary risks, I think company risks are less scary to people in mining companies than technical risk.
Yeah,
which may not be right.
No, but I would agree that that's where the mentality sits for sure.
Yeah, but I think there's probably good justification for that, because unfortunately the world is full of failed metallurgical processes, and in terms of managing country risk, there are well-defined tools for doing that, partnerships and JVs and all sorts of other things.
Success kind of begets the same conventional processes being used, whereas failure doesn't necessarily lead to people changing the ways. So failure of a new process basically means that people go back to a conventional one.
Yeah, I mean, that happened, in pyrometallurgy, that absolutely happened. So zinc smelting, a new process was being introduced that I worked on, a competitor called the QSL process that was being brought in the late 80s. It failed spectacularly, cost a company in Canada a lot of money. They had to run their conventional process for a lot longer. Eventually, they went to a somewhat better tested process. But these things, whether it's the HBI plant here in West Australia or lots and lots of other things, their metallurgical failures are unfortunately, technical failures are unfortunately very common and very, very expensive.
That I've experienced in my career is the sort of mentality of that we'll solve it along the way. What concerns me is, again, as average grade declines, that will create more and more error. Do you think that's another area that we need to change?
Well, I totally agree. I mean, well, I guess there's two parts of that. One is we've developed our if you say in Australia or Canada or countries like that, we've developed our metallurgical processes to cope with the ore bodies that we have, and generally we've been quite successful. But those ore bodies move, as you absolutely pointed out, and over time they get harder and harder, and they go places where actually the process that we've got doesn't really suit it anymore. But if you haven't got the pattern of innovation and the understanding of how you can change your processes as your ore bodies change, if you haven't got that ready, really all you're facing is closing up shop. And if you had different technologies ready, who's to say that you couldn't mine and process there a lot longer?
I mean, people don't want to shut mine, especially these long life mines that have been open and had a real impact on society. They don't want to shut them, so they've got to think of ways of keeping them going.
Yeah, but the processes have to be ready, because obviously people have limited patience and limited cash. So the processes have to be ready, whether it's an old mine or whether it's a new mine with lower and more complex ore. They've got to be ready, and the question is, are they? Are we developing processes like that?
So as someone that's worked in these companies, how much success have you had convincing companies to have, say, a plan B, a C, or a D, depending on how the ore body changes?
Well, I think that, those mining companies are full of clever people, but they have real constraints on them. And I think, one of the other aspects of the mining industry that's really unhelpful is the endless swing of commodity prices. So when the commodity prices are down, and let's face it, that happens a lot, it's very hard to justify any degree of long-term investment. And new metallurgical processes take sustained long-term investment. So it's hard for companies in mining, even though they might know that there is a crisis that's looming maybe a few years out, getting the process ready to change to deal with that new ore body can be very hard. I mean, there are some companies that are sufficiently profitable and have the resources to be able to get ready and change as their ore bodies change, but not every company is like that. And I would say it's patchy. Some companies can do it, some can't, but it is a real challenge.
In your opinion, then, do you think that the greatest barrier to technological innovation in mining is the underlying economics of the industry?
Yeah. I mean, fundamentally, I do. I mean, I think it's the economics, which means those factors I said before. I mean, so it's the information, it's imperfect knowledge of the ore body. It's not knowing what you're going to get when you actually start digging. You don't really know that. And you don't know that day by day. So lack of information and lack of confidence in what you're going to get is incredibly difficult. And then when you multiply that by the fact that the commodity prices can be all over the map, that economic playing field is what makes it really hard.
So are some of the changes towards real-time analysis, is that going to solve some of these issues?
Without a doubt. I mean, I don't know if it's going to solve it, but without a doubt, I mean, I personally think the biggest change in mining maybe ever is upon us right now. So being able to figure out what you're going to get before you get it, because you've got more sophisticated analysis, more data, more robust mathematical methods of figuring out what's in the ground, and therefore the opportunity to do feed-forward control, to look ahead and say, okay, we're going to get this today, let's set things up. And also feedback control. You can understand how that stuff performed, and you can learn from that, and you can adjust your processes appropriately. So more information, to me, is key to changing mining from, the rather chaotic thing it is now. It resembles a battle, to be honest. It changes it from, a battle to a process, to a production process. And I think that the heart of that is information, and that's what we're going to have, or what we're having for the first time, really.
Is it really going to sit then with the big diversified majors to drive this, the ones that can afford this longer term vision?
Well, I think it will for some things and it won't for others. So for new metallurgical processes that complex and depleted ore bodies require, maybe the majors will do some of that. Other people will do other bits. I'm not sure that I think a lot of innovation is going to come from outside of, say, North America and Australia. I think it'll come from China, India, places like that for development of new metallurgical processes, personally. Other forms of innovation and using information more effectively, yep. I mean, the big companies are already profiting from that and will continue to do so, but it's going to filter down, and the relentless march of technology and the great dropping of barriers to technological implementation, that's going on all over the place. So you don't have to be rich now to be able to do all kinds of really amazing things. And so I think a lot of it's going to come, from the majors, but also smaller companies too.
So let's talk a little bit about the Mine of the Future program at Rio Tinto. That's a program you were involved in, and that's probably one of the obvious cases where a company adopted a slightly different strategy than, say, what the industry on average was doing. So this strategy of being a first mover rather than first follower.
Rio was absolutely the first mover really going into technology before a lot of other companies did. Versus, when I was in BHP, we were proudly fast followers. We wanted to be the first of the second kind of thing. Why would you want to be a first mover versus fast follower? What are the advantages and disadvantages in mining? It's always paid well to be a fast follower because you let some poor devil develop something and fail. And also the development time typically of many metallurgical processes and innovations is very long. So you can watch them for a long time to see whether or not you want to jump on board. And meanwhile, some other, poor devil is spending a lot of money to develop it. So there's a lot of risk associated with development, and there's been zero risk in being a fast follower. You just sit back and watch, and when it looks good, you just jump in and share the benefits. I think there are real risks, however, especially now, with being a fast follower, and that's if the first mover gets in there and races away and secures key patents in areas that are fundamental to new mining processes, then fast follower can find themselves with big headache figuring out, if this technology or this approach is locked up, what are we going to do? And simply relying on equipment manufacturers to provide you with technology, as the fast following technique has tended to do. If the equipment manufacturers are just selling the hardware, but a mining company has the use of that hardware locked up in intellectual property, there is significant downside risk for the fast follower. That tug of war between first mover and fast follower is an interesting one. And like I said before, typically in mining, fast follower has been a good strategy. I don't know if that's always going to be the case.
The way I sort of look at it, there are things that are of incremental value, like moving towards bigger trucks and stuff, which you can afford to watch. And even the move towards autonomous mine, that strikes me as something you could watch. But what about something radical like in situ leaching of ore bodies, something that would actually be a disruption or potentially a disruption?
I guess I disagree with the idea that automation is incremental. So I think the face of it, that looks like it's an incremental change, but the reality is automation has a possibility to completely change the mine fundamentally. And because of the flow of information and the fact that equipment will do what it's supposed to do, not, follow an unpredictable path when it's operated by a human, trucks turn into conveyor belt and drills turn into immense sources of information. The whole mine actually completely changes. So I don't think that automation is incremental. I actually think it's quite different. And that's what I was saying before. I don't think anyone can afford to sit on the fence with automation personally. things like in situ leaching and other things like that, if you take in situ, that technology has been around for a long time. And people were doing in situ leaching of uranium 50 years ago. And they've been in situ leaching of salts in my home province for probably about that long. In situ leaching is well defined, and there are some ore bodies for which it works, and there's some ore bodies for which it doesn't. It's an alternative for working on a certain type of ore body under certain circumstances, but it has a lot of risk with it. And so, I don't view, to me, in situ leaching as just one of a number of metallurgical processes that are available and have been developed. And it shares the same hallmarks as any new metallurgical process.
I mean, that's a really interesting perspective because obviously, coming from an outsider's perspective, I guess I asked the question from a degree of radicalization. Something that looks like what we do seems like an increment. Something that doesn't look like what we currently do is out there. Your point taken about innovation and what it actually is going to enable is just fascinating because that's not something I've even really thought of in detail. So do you think that this is driven by safety or is it really driven by costs?
Automation, it's driven, in mining, as you well know, those things, safety and environment are incredibly important. And in my view, I'm concerned about the environment. Environmental pressure has been a major source of innovation, particularly in the processing area. So those are absolutely important drivers. But of course, so is productivity. And I think what occurred is in terms of automation, people immediately kind of looked at it and saw, okay, well, we can get a certain amount of benefit from taking people out and replacing them with machines. But if you're a mining company, that does not really look all that interesting in terms of value, because what happens is equipment manufacturers rapidly figure out what removal of a person is, and then they charge you that much for the equipment without the person on it. So, they just capture the rent. They're not stupid. And also, mining companies got a social responsibility in many places to employ people. So removal of people is not typically an interesting economic driver. It can be useful getting people out of the line of fire. That's incredibly important, and safety is incredibly important. And there are some cases where you would just do that. What is more interesting in terms of throughput is the ability to optimize. And if automated equipment gives you more information, gives it faster, and allows you to do things in a way that you could not do with humans, then that becomes, potentially really interesting. Not the simple removal of a human from a piece of equipment.
Do you think automation is currently the most untapped innovation opportunity in mining? And if not, what would you say is?
Well, personally, I would say that the twin sort of things of automation and information, those are the things that are fundamentally important and will, I believe, radically transform mining and are transforming mining. So being able to take all the data that we have and turn it into information, and then being able to make better decisions based on that information and carry out processes differently based on that information and based on new automation that you have, will radically transform mining. Like I said, it will change it from the battle that it is, where every day is different and it's continuing struggle to ensure that things are working properly, to much more like a manufacturing process and other industrial processes where material flows are defined and known and things are predictable and reliable. Those are not hallmarks of mining now, and I believe that they will become hallmarks of mining primarily due to information and automation.
So should we expect AI to have a significant impact on our business in the coming decade?
Sure. I mean, that's just, one suite of technologies. I mean, yeah, sure. Why not? All forms of information processing. Absolutely. Whether it's some sort of neural net or whether it's something that's based on physics and laws of conservation of energy and math, whatever it is, being able to make better decisions based on information is going to be critical. And because we've got more information and we've got more computing power and we've got the ability to carry out commands better, all of those things are going to make a big difference. So yeah, AI is just one of a number of technologies that are going to make a difference, sure.
So one of the things that I think of when I think of the laggard nature is the stereotype of the mine engineer, or could even point a finger at ourselves, the mine or exploration geologist. One of the things that will change is that we will become more data science oriented, both engineering and geoscience.
Yeah, well, that's right. That's actually the biggest problem we've got, because right now we've got really smart people who are really good at dealing with the way mining is now. But those people, they don't necessarily have the best skills to take a mining company, mining industry rapidly where it's going to go, and also to take advantage of new technologies that are available. So I think that the mining engineer of the future is going to greatly resemble a process engineer, where they'll have process skills and worrying about all the things that a process engineer worries about and that a mining engineer absolutely doesn't worry about. And, I've had some conversations with people in the educational system, in universities and whatnot, trying to say, well, it's great you're teaching people to be mining engineers, but I think you're teaching them to be mining engineers of the past, not the future. I think it's got to change.
That's just an awesome comment, because that's something that we face on a day-to-day basis in geoscience. And one of the reasons we set up this podcast was to reach out to the 30-year-olds and empower them and have conversations and inform them really of where we're going, and that much of the change is going to come from their age bracket, from a different generation.
Well, it absolutely is. I mean, when I hope I'm not telling stories out of school, but when I worked, in Rio Tinto, surface mining automation group, I had 30 odd people all working on new technologies, and I was supported by maybe 100 people in India doing that, and we had lots of contractors and lots of people doing stuff. And in the whole group, I had one mining engineer. They were all either process engineers or chemical engineers, a lot of mathematical people, software developers, all that kind of stuff. But the future in mining is not being made, unfortunately, by mining engineers right now, and universities need to think about that.
So, Andrew, do you ultimately believe that the mining industry is a laggard when it comes to technological innovation, or do we just do it differently?
I don't think that's really the right question. I mean, I think, has it lagged behind? I mean, the purpose of the mining industry is not to be a technical leader. The purpose is to provide those things that we need for our society, and to minimize the impact and not hurt people. That's why you have a mining industry. It's the purpose of it isn't innovation, but the purpose of innovation is to make all of those things better if you can. So the mining industry has got a certain level of technology development, and I guess the question is why is it the rate that it's at, and will that change, and can you do anything to speed that up, rather than is it a laggard? Well, it has some rate of technical development that suits it, actually, but is that going to change, and should it change, and how do we make it change? So my view is, I think the relentless improvement in computing and information technologies is going to have a very big impact on mining, and that it will change, and it just has to change, for certainly in terms of mining operations. But new metallurgical processes, developing new metallurgical processes, the rate of that development, I see that as very much slowing down in the West, and the baton, if anything, is being passed to countries like India and China that have got the absolute need for new innovative technologies to suit their ore bodies, and the willingness and the capability to go ahead. In terms of innovation, I'd say they're sort of like operating now and using information. That's really important, and that's happening. But also new metallurgical processes, I think we're going to have to look to other countries for that.
So that's a pretty picture that you're painting of the future of mining. I mean, this should be a time that you want to be involved in the game.
In Australia, Canada, US, West, yeah, absolutely. Information in mining it's fascinating, it's fun, it's important, and it's underserved. And so, yeah, I think, you got to learn the jargon, you kind of got to learn, what miners are on about. But if you're mathematically skilled or have that kind of approach to things, yeah, I think there's a lot of value you can deliver. Absolutely.
So how can we get more of that sort of people into our industry, or how can we educate a broader group than the traditional mining company employees?
Yeah, I agree. I mean, it's chicken and egg. So the trouble is that because mining companies are full of talented and intelligent people whose background suits the status quo rather than the future, and they're busy and they have a lot of pressure on them, it's difficult often to get them to understand what new analytical approaches can do. And so if they've never seen it before and they don't understand it and they're busy, it's often hard to convince them of that. So I think what mining companies need to do personally, and this is something I advocated, was they need to send their people back to school. They need kindergartens inside their companies to learn how to develop and deploy and use these new technologies as effectively as possible, as quickly as possible. So companies got to grab a hold of that. And also companies, I think, have got to lead the way with universities. So universities have got to start turning out people with mining degrees that understand process control, statistical analysis, and, mathematical modeling, and all those sorts of things that really weren't anywhere near as important as they are now.
In the end, this was a story about the future of mining engineers, not geologists. But just remember, they are the very people who run our industry. So this makes us ask the question, who is leading the change? So come on, speak up. Your opinion is more than wanted.
It's a really interesting time to be in the industry, and I think what you guys are doing is great. I mean, you're asking the right questions, and hopefully you can, provoke good discussion. I think it's a good thing.
Join us next week for another episode on Exploration Radio.